Hey middle school algebra students, this is Mr. Schultz here with you, and we're going to take a look at lesson 6.1.1, which is called How Does the Pattern Grow? And the big topic here is representing exponential growth. Exponential is going to be the kind of key thing here. It's going to be a different growth than what we've been doing with lines. So before we get started here, make sure that you have a piece of paper and a pencil and that you are taking notes, not just watching, but actually writing things down. It'll just really help you remember it, and it's really good practice here. Math is a doing thing, so make sure that you're doing and not just watching. So let's read this intro. So far in this course, you have been investigating the family of linear functions using multiple representations, especially tables, graphs, and equations or rules. In this chapter, you will learn about a new family of functions, exponential functions, and the type of growth it models. So we'll be using this diagram that we've used before of converting between tables to situations to equations to graphs and any other of the ways. Let's see what's next. So in problem 6-1, multiplying like bunnies. In the book of Mice and Men by John Steinbeck, two good friends named Lenny and George dream of raising rabbits and living off the land. What if their dream came true? Suppose Lenny and George started with 2 rabbits, and during the first month, those rabbits had 2 babies. Also suppose that every month thereafter, each pair of rabbits has 2 babies. Okay, so let's think about this. And first off, let's just laugh a little bit about this situation, about rabbits and all the other topics that go with this. So here it says this. So they're starting with 2 rabbits, and during the first month, these 2 rabbits have 2 babies. And suppose every month thereafter, each pair of rabbits has 2 babies. So you have 2 rabbits, and they have 2 babies. But now the next month, each pair of rabbits has 2 babies, meaning that these 2 rabbits would have 2 babies. Let's do that, B for babies. And this pair of rabbits would also have 2 babies. Then so that's after 1 month. Now after 2 months, then each pair of rabbits would have 2 babies. So let's do a different color. So now these 2 rabbits would have 2 babies. These 2 rabbits would have 2 babies. These 2 rabbits would have 2 babies. Sorry, that's a crazy looking bee. And these 2 rabbits would have 2 babies. So that's what it's talking about here. Now let's look ahead and see what the questions are around this. So your task on 6-1 is to determine how many rabbits Lenny and George would have after 1 year, which is 12 months, and to represent this situation with a written description of the pattern of growth, a diagram, and a table. So we want to make a pattern. We want to make we want to make a written description. We want to make a diagram, and we want to make a table of the growth that was described in the previous problem. So our task here is to determine how many rabbits Lenny and George would have after 1 year, which is 12 months, and then represent this situation with a written description, a diagram, and a table. So let's try to figure this out. How many rabbits would Lenny and George have after 1 month? Okay, well, going back to our diagram here. Now remember, I made this diagram on the last page. It started to get a little bit crazy, so let's see if we can clean it up with the table. So these are our months. These are the total number of rabbits we had. So in that first month, so in month 0, which is what I had in the red ink, we had 2 rabbits to start. That's how many they started with. Then those 2 rabbits had a baby, or had 2 babies after the first month, which made a total of 4 rabbits. Because I had the 2 that we started with plus their 2 babies, which made a total of 4 rabbits. Then in the next month, each of those pairs, so this pair and this pair, each had 2 babies each. So now I've got 1, 2, 3, 4, 5, 6, 7, 8 rabbits in total. Then in the third month, those 8 rabbits, each pairs of those had 2 babies. Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 rabbits. So you can see that this is kind of growing very, very quickly here. So, but we might be able to find a pattern and just start to be able to predict Well, it looks like, well, see what you can find. Is there a pattern here? Pause the video and see if you can figure out what is that pattern that's changing the total number of rabbits. Okay, hopefully you came up with that your pattern was times 2. So we're predicting that 16 rabbits is going to turn into 32 rabbits. And then in month 5, that 32 rabbits is going to turn into 64 rabbits. And we're just going to keep going down this table until we figure out how many rabbits there are in month 12. So let's see what that looks like. So there we go. 8,192 rabbits after 1 year of them doubling. That's crazy. So when we're thinking about this, we've got our table. We kind of had this diagram here. It wasn't the cleanest thing in the world, but it definitely worked for what we were trying to do there. But lots of different ways that you could have made this. So our last piece here, since we got the diagram and the table done, is we just want to look at the written description. And we could say something like, they started with 2 rabbits and they doubled it each month. Each month. That would be a great written description about how this pattern is growing. Okay, let's take a look at the next part here. Okay, so the second part here, state the assumptions you made when you modeled the number of rabbits raised. Well, I would say there's a whole bunch of assumptions made here. You could be going in a lot of different directions here. Like for example, in the diagram when we had our first set of rabbits. In fact, let me pull that in here just a second. Okay, well, we assumed that these first 2 rabbits had 2 babies and that it stayed at a constant pace, that they were always going to have 2 and that they always lived. Well, what happens if a wolf eats one? What if after 1 month 2 baby rabbits aren't ready to have 2 more baby rabbits because they're just not old enough yet? What happens if these 2 baby rabbits are not the correct gender to be able to have babies? Whole bunch of different things that could have gone wrong there. So just lots of assumptions that we were making just based off of what they said in the question. And then last one, compare any patterns you find to the other patterns we have investigated previously. We definitely have seen some growth things like this before. Things have doubled or tripled or something like that with some of our tile patterns. So let's take a look at the discussion points next. So the discussion points here, it says, what strategies can help us keep track of the total number of rabbits? What patterns can we see in the growth of the rabbit population? And how can we predict the total number of rabbits after a certain number of months has passed? This is really our big key question here, because we know it's doubling, but we kind of always need the month before that. So looking at our table, to know what month 7 was, we kind of need to know what month 6 was, and 5 and 4. Then eventually we can kind of work our way up. So eventually we're going to move into some stuff where you want to be able to try to be predictive, and usually that ends up being some sort of a rule. So we are going to talk about this stuff more as we keep moving through this lesson, but that's it for today. We'll take a look at day 2 for tomorrow. So that's it. Have a great rest of your day.